This is going to be the companion video for the PowerPoint lecture that we looked at for Thursday. So what we're going to need for this is we're going to need that E6B, electronic or mechanical. You are going to need your plotter, and you're going to need that Indiana sectional chart substitute that we got there. So we could go out and purchase a current St. Louis sectional. If we were actually flying this in the aircraft, we would have to go out and buy that current St. Louis sectional. However, because we're just doing this in the classroom exercise, those Indiana DOT charts that we got will actually work just fine. So we are going to take into account some of those other performance factors we talked about. We're not just going to do that over a simplified point A to point B calculation that we did last time. We're going to have to get into the performance manuals. For this one, we're going to be using the Cessna 172S manual, section 5, the performance section. And like we talked about in that PowerPoint slide, Cessna does give them to us in tabular format. So they're going to be a little easier to run the spaghetti charts that Diamond gives us. However, we are going to have to do a little bit of interpolation for those charts, and we'll annotate those when we have to. So before we get going, what we're going to have to pull up from this performance chart is our time, fuel, and distance to climb, which we'll reference in the chart. And we'll also have to get our cruise performance chart. So we'll take a look at those. We'll get those numbers first, and then we will get going with the actual calculation piece. Before we get going on those charts, one thing we're going to have to look at are some of the given conditions. So for our given conditions, we're just going to go ahead and assume that the aircraft does weigh 2,550 pounds. And we're also going to go ahead and assume that it's going to be a standard day. That'll make our calculations a little bit simpler. Now, if you take a look at Evansville to Monroe County, Kilo Echo Victor Victor to Kilo Bravo Mike Golf, it is going to be easterly. So we're going to go ahead and say that we decided our cruise altitude to be VFR hemispheric compliant is going to be 5,500 feet MSL. And we'll go ahead and say we looked at aviation weather or for flight and determined that our winds aloft for most of our flight are going to be 190 at 15 knots. So remember that the chart and the winds aloft are given in true. So we will have to run through all those calculations independently to determine what our actual magnetic heading is. So let's get going to the charts. So here's our starting point, Kilo Echo Victor Victor or Evansville Regional. All right, we could look up in the airfield facility directory, or we could look at the information box here for the airport. We're going to determine that the field elevation for Evansville is going to be 422 feet MSL. So we're actually starting our climb at approximately 500 feet. So we'll have to take that into account with our calculations as well. We jump over here in the time, fuel, and distance to climb at 2,550 pounds chart here. We can see over here on the far left, that's the pressure altitude that we're going to be climbing to. And here's going to be how long it's going to take us to climb up there from sea level. Now we're starting off at 500 feet. Remember, we're going up to 5,500 feet. So we are just going to climb 5,000 feet. So we can go ahead and use that 5,000 foot pressure altitude there since we're just climbing 5,000 feet. So here's the information we need from that chart. All right, we can see that our climb speed is going to be 7 to 3 knots indicated. Our rate of climb, it's not going to be that great. We're going to average 550 feet per minute. Now here's the piece of information we actually need here. It's going to take us 8 minutes to make that climb. We're going to use 1.9 gallons of fuel, and it's going to take us 10 nautical miles across the ground to get from our point of origin to our cruise altitude. So go ahead and jot down the time, the fuel, and the distance, and we'll be using those later on in the calculations. The next piece of information we're going to get is going to come from our cruise performance charts. This is where we're going to get our true airspeed and our fuel burn for our cruise portion of flight. So again, we're going to be cruising at 5,500 feet. This chart is given to you in pressure altitude. So we do have the opportunity for a little interpolation here. We'll just go ahead and get some approximate values here. 5,500 feet, pretty close to 6,000 feet. We're going to make sure we reference the standard temperature block here. And we're going to go ahead and say that we're going to use about 2,500 RPM. We don't want to use a high-speed cruise regime because it's going to be less efficient, but we also don't want to fly too awfully slow. So we take our 2,500 RPM value. We come across the standard temperature box here. We can see that the engine is only going to be producing 65 horsepower at that power setting. We'll be doing 114 knots true, and our fuel burn is going to be 9 gallons an hour. So again, we're going to have to jot down our true airspeed and cruise is going to be 114 true, and our fuel burn is going to be that 9.0 gallons per hour. Now last time when we did the first one, we just did the one straight leg from Terre to Evansville. So if we did this on this one, we'd have a straight leg from Evansville up there to Monroe County. We can see that would be an 80 nautical mile leg. However, we said for this one, we want to start putting navigation checkpoints about every 20 miles along the route. That'll break it up into different legs, and then every leg will force a new navigation calculation that we need to perform. Now, you recall from that time, speed, and distance to climb, we said it is going to take us 10 nautical miles to climb. So using the sectional chart scale on the plotter, we park our reference there, and at 10 nautical miles, that's where we're going to reach our cruise altitude. Now, keep in mind, even when we're climbing, we're still going to have to start navigating. We're still going to have to start looking for checkpoints and landmarks here. So what we can do here is we can go ahead and find a prominent landmark that's approximately along our route of flight and find out where that's going to be about 10 nautical miles. Now, once we lay the plotter on there, we can see that if we were flying the appropriate course, that 10 nautical mile reference is going to fall just past Elberfeld along Highway, 64 here. All right, so we could potentially use the intersection of this railroad track and this major highway here to denote our top of climb. So we'll go ahead and draw ourselves a little line there, and then we'll go ahead and determine what our approximate course will be for that first leg. All right, so instead of having leg one, this will be our climb portion. All right, so we'll call it 10 nautical miles, and over here we're going to have to come up with a course for that. So just like we did on the last one, we want to go ahead and align our straight edge with that course line, get those lines roughly parallel to one of those lines of latitude or longitude. And under the course line, we can see our initial true course for our climb. We'll go ahead and call it about 033 true. So we'll jot that down, and we'll keep that for later when we start doing all those individual calculations. We've got our top of climb point denoted on there. So the next thing we're going to want to do is you're going to start to pick prominent VFR landmarks approximately every 20 nautical miles. So we could try to keep them relatively in line. We can kind of see here that if we put that on there, we really don't have a prominent landmark at that 20 nautical mile point. So let's just go ahead and say that we're going to shift it up here towards this little town of Alfred, Indiana. I'm sorry, that's going to be Petersburg, near that Alfred Private Airport, and we'll use that for our next particular navigation leg. We can see that is going to be 20 nautical miles, so we'll jot that down, and then we'll go ahead and come up with a true course for that one. Again, keeping it all lined up with a straight edge, we spin it in with our plotter, get it relatively lined up with a line of latitude or longitude, and we can see our true course. That's going to get us from top of climb to that first navigation waypoint is going to be approximately 020 true. For the rest of the route, I went ahead and chose checkpoints approximately every 20 nautical miles. Now, they don't have to be exactly 20 nautical miles, just somewhere in that ballpark there. If it's a little more or a little less, that's fine. I went ahead and I connected them all with a plotter, but I was sure to annotate all those navigational checkpoints with some sort of horizontal line so that they're easy to pick out where those checkpoints actually are. Then what I did is I went ahead and I just took like a green highlighter or something. I went over the route so that we're looking at this in the aircraft. It's easier to see a highlighted route than just a little pencil line drawn on there. So now we just need to break it down step by step, get the true course and the distance with a plotter, and then start running through the calculations. So we do these leg by leg. So for top of climb to Petersburg, we lay our plotter across, again making sure we're looking at the correct ones. This one works out to basically right at 20 nautical miles. Now I went ahead and broke down all of our equations so far with individual course calculations, and I broke it down. So we got our distance for that first leg. We'll call it our top of climb to Petersburg. We'll go and say that that one is 20 nautical miles. Now we'll go ahead and get the course for it using our little course arrow here. Spin our bezel until we're lined up along a line of latitude or longitude, and then we can read under there that we get our true course for that particular leg. We're looking at approximately a true course of 020. Now we'll bring that over and we'll plug in that first true course, that 020 for our top of climb to Petersburg, and then we'll continue that process for the rest of the checkpoints that we have along the route. So if you do have your sectional and your plotter available, use approximately those same checkpoints, and then I want you to go ahead and come up with the distance and the true course for for each of those individual segments. So here are the values that I came up with here. From our top of climb to this little town of Petersburg, I came up with a true course of 020 and a distance of 20 nautical miles. Now for my checkpoint after Petersburg, I picked this small lake here just east of the Davies County Airport. Where I drew that line, there is a small dam in it, and it is just off from this little town here. So that should be a pretty prominent landmark. The course and distance I got from Petersburg to that lake that I'm using for my next landmark was a true course of 038 and a distance of 21 nautical miles. The next checkpoint I used from that lake was this little town here to the southwest of Bloomington called Cincinnati. Now we do have a pretty decent road coming out of the little town of Bloomfield here, and we do have some high tension power lines. Some towers are going to help us draw our eyes to that waypoint, so that's why I chose that one. So from the lake to that little town of Cincinnati, I got a true course of 043 and a distance of 20 nautical miles. And for our final leg there, from Cincinnati to our ultimate destination of Bloomington, true course of 040 and a distance of 10 nautical miles. Now that we have all that information, we can pull up our E6B and start running through those calculations.